In this video, let's see how we can test on differences between means of two independent samples when we assume unequal variances. So over here, we have the same hypothesis that we're testing the means, whether they differ or not, but we assume unequal variances. So we're going to write unequal variances right next to it like that. Now here it's a bit more simple because we don't need to pool one standard deviation. So the formula is going to be slightly faster. We're going to have a t value where we take the same differences between those sample means, so x bar 1 minus x bar 2, and we divide by both. Standard deviations. We keep them both into account. So it's going to be the standard error written in the following way. It's going to be the square root of the first variance divided by the number of observations in the first group plus the square root of the second variance over the number of observations of the second group. We take this together in one square root. This is going to be our t value. Now, as always, we're going to compare this with the t critical value. Let's see what the t critical value is going to be. We're going to have over here the t critical value at the significance level alpha divided by 2 because it's a two-sided test. Now, the degrees of freedom is going to be the lower number between the number of observations of the first group minus 1 versus the number of observations in the second group minus 1. So the minimum between n1 minus 1 versus n2 minus 1. Whichever is the smallest is going to be the degrees of freedom that we are going to consider in our t critical value. Now, with the same logic, when we want to design the confidence interval, I'm going to go slightly in the right corner because there's literally no more space. So if we go over here to design the confidence interval, again, the confidence interval will have the same logic. It's going to give us a range where we actually have the difference between the population groups with a 95% probability, assuming it's a 95% confidence interval. And that's going to be based on the sample mean differences, like here, x bar 1 minus x bar 2. X bar 1 minus x bar 2, same logic. Notice the analogy, the same, the same structure. Plus minus the t critical value. Well, if that was the t critical value there, we're going to use this t critical value in our case. So we would have the t critical value at 0.025 and the minimum between those two. So it's going to be the minimum between n1 minus 1 and 2 minus 1. Hope this is still visible like that. And that's going to be multiplied with the standard error. And the standard error is what we have in the t-test. So this one, the square root of all that. So we're going to multiply with the square root of. We're going to multiply this with the square root of s1 squared over n1 plus s2 squared over n2. And notice this belongs to all the cases. The confidence interval, we're using pieces from the test. We're using the critical value that we found. We're using the standard error that we have in the actual test. So that the confidence interval, when we design it, we don't have to remember anything. We just take pieces that we already used. So this is going to be the confidence interval. And that's where we sum up the tests on differences between means when we have independent samples. In the next videos, we're gonna go to, let me just go over here to not make it messy. We're gonna go to tests on differences between means when we have dependent samples. We're gonna work on the matched pairs t-test, and then we're gonna work on the sign test, and afterwards we're gonna go and test on differences between proportions.